So this is the fourth and last type of compound group that I mentioned in the very beginning, which I know feels like 6 months ago. But there's four types of compounds that we've looked at as far as how to both name them and write the formulas. So the first three types are relying on a metal plus a non-metal, which means you basically have a plus half and a minus half. And so when we write formulas, that's based on a balance of charge between plus and minus, okay? And when we name them, we look at whether there are only two elements or more than two. We look at if the metal has more than one charge to decide which of those three systems that we use. So the first example that we went over were the binary ionic compounds, where you have only two elements, one metal, one non-metal. And the metal has only one charge. So it's just the metal name plus the non-metal name, and everything ends with IDE. The second one we looked at was when the metal has more than one charge, mostly from the transition elements. That's why I give you the periodic table, which shows you the different possible charges. And then we have to use something called the stock system, where you put the Roman number in brackets after the name of the metal to indicate what the charge is. The last one that we did were the polyatomic ions, where you have groups of atoms that form one particular unit. And so in that case, you would look at a formula. If the formula has more than two atoms, then you're looking at part of your formula, part of the name being from that list of polyatomic ions. Now, this last system is different from the other three in that it is dealing with two elements, but both of them are non-metals. So just to give you, I think I have a periodic table in here. Okay, we're not studying organic chemistry. So, oh, do I not have it? Here, it's in my library. There you go. Come on. Open. There. Okay, and it's got scribbles all over it as usual. So remembering back to what separates non-metals and metals, maybe I use the highlighter this time. Starting under boron, we just kind of make stairs like that. And it's not exactly like this. The lines might be a little bit different, but just to make it easy, I just do stairs, because then you know around the stairs, that's where the cutoff is. So all of these guys are considered non-metal. So it's a very few number of elements that you're actually dealing with in combination for this type of compound. So in this case, we're going to use something that's called the prefix system. And we use these prefixes to indicate the number of atoms, because nonmetals are all negative charge. So it has nothing to do with charge anymore. When you're putting formulas together, you're only looking at the name of the compound. You're not looking at charge at all. So forget about charge for the last kind. I think, from 5 to 10 should be the same as in geometry. If you study geometry already, you know that 5 is penta, like a pentagram, 6 is hexa, 7 is hepta, 8 octa, 9 nona, and 10 deca. The ones that might be new, or maybe not, I'm guessing you've probably seen them around: 1 mono, 2 di, 3 tri, 4 tetra. So in this system, before the name of the element, we put the prefix that indicates how many atoms of that element are in there. And you've already seen an example of this system in action. You've just never had to think about why that's the name before. And the most common example, CO2. And we all know the name of CO2 is carbon dioxide. Now, you might think to yourself, well, carbon doesn't have a prefix on it. That's correct, because the only exception, or the only rule that's an exception, is that if the first non-metal, there's only one atom in it, you don't need a prefix. I don't know why that's a rule. I'm sure there's a reason for it, but if the second atom is only one, you do need a prefix. So if the first atom has only, if the first element has only one atom, you just use the name of that element, and then you use the prefix, so that's carbon, and then you use the prefix for oxygen for 2, which is di, and then the name adds an ion, even though it's not an ion, it's not a charge, but it's dioxide. So again, everything ends with IDE, but it has nothing to do with charge. So if I do something like P2O5, again, the first element name stays the same, and you use a prefix to indicate how many atoms of that element are there. So prefix for 2, again, is di. I'll just put that up here. Can I make that smaller? No, okay. So I've got di, and P is phosphorus. And then the only difference is when it comes to, and I don't even care if you remember this or not. If you forget, that's fine. I won't take marks off, but just if you want to know, when you're dealing with numbers 4 through 10, that all the prefix all ends with the letter A, so like tetra, penta, hexa, hepta, octa, nona, deca, and your element name starts with a vowel, we usually drop the A, because I'll show you, for example, 5 is penta, and then oxygen is oxide, and saying pentaoxide is awkward. So we just cut the A out and say pentoxide. See, so much easier to say pentoxide. Diphosphorus, pentoxide. And that's it. This should be the easiest, I think, of all of them, because the name is literally instructions on what the formula is. If I say tetrachlorine heptasulfide, I'm just making stuff up now. Tetrachlorine heptasulfide. This is not actually a compound. I just made it up. But you look at chlorine is Cl. The tetra tells you that chlorine is 4. And then sulfide is S. Hepta means 7. Cl4S7. Not too hard, right? Let me find some practice. Stop that first. Documents, people names. I know I have. Okay, once I get started. Right, is it gonna open? No. Okay, try it again. Okay. All right. Trying to find the correct section here. Here we go. All right, so if we look at this one, chlorine monoxide. Chlorine monoxide. Okay, so I can't write on this because it's a picture, but anyway. Chlorine, of course, is Cl, and then monoxide means that there's one oxygen. So this formula would be ClO. Oxygen difluoride, again, if the first one doesn't have a prefix on it, it means that there's only one atom. So this is O and then F2. Oh, this is actually wrong because that should be monophosphide, but anyway. When you have dinitrogen monoxide, the di means that there's 2 N, so it's N2O. Monoxide is 1 oxygen. Sorry, my dog just barked. diphosphorus pentoxide, P2O5. And let's go to some formulas. Wait, are formulas just names? I guess so. All right. How about you do numbers here, 15 to 20. 15 to 20. I'm gonna go find